Welcome to In 5 Minutes. In this video clip, we will discuss sampling theorem for bandpass signals. Previously, we have already discussed sampling theorem for low-pass signals, in which we had derived this very important expression that sampling frequency that we need for the sampling of the low-pass signals has to be greater than equal to twice FM, where FM is nothing but the bandwidth or the maximum frequency of the low-pass signal that needs to be sampled. Now, when it comes to sampling the bandpass signal, let us see why I can't use or I should not use the same sampling theorem which is defined for the low pass signals. And before we discuss that, let's quickly try to understand what exactly is a bandpass signal. So a bandpass signal is nothing but a signal in which there are frequencies present from some specific frequency value FL up to some high frequency value FH. So there are frequencies only from FL to FH present in that particular signal, and no frequencies below FL will be present in the signal. In simple words, no low frequencies are present in the signal. The signal consists of the frequencies in the range FL to FH, and because it consists of a band of frequencies between two frequencies FL and FH, we call it a band pass signal. Lot of signals in practice are of band pass in nature. For example, all the modulated signals that we have discussed so far, for example, amplitude modulated, phase modulated signal, etc., are of band pass in nature. If you remember, an amplitude modulated signal, it is present around carrier frequency Fc, and the minimum frequency it has is Fc minus Fm, and the maximum frequency it has is Fc plus Fm. So it consists of only those frequencies from Fc minus Fm to Fc plus Fm, and hence it becomes a bandpass signal. For such a bandpass signal, we define an important parameter called bandwidth. Bandwidth we are writing as B as of now is nothing but Fh minus Fl. Fh is the maximum frequency and Fl is the minimum frequency, highest and lowest frequencies present in my bandpass signal. Now let us talk about what should be the requirement in terms of sampling frequency. What should be the value of the sampling frequency that I should use for the sampling of such bandpass signal? Please note that what we had drawn is the frequency spectrum of a bandpass signal with respect to frequency f, and that's how we have defined its bandwidth, which is Fh minus Fl. The sampling frequency for the sampling of the bandpass signal can simply be given as F is equal to twice Fh minus Fl, and as per the definition this can be simply equal to twice B. So as of now we are not defining any range for sampling frequency saying that it should be greater than some value. We are simply saying that the sampling frequency that can be used for bandpass signals has to be equal to twice Fh minus Fl. But for this to be a valid sampling frequency, there is a condition that needs to be satisfied. Now what is this condition? The condition says that either Fh or Fl should be harmonic of Fs. So only if Fh or Fl, either of the two, is harmonic of Fs, only then this is a valid sampling frequency that can be used. If the condition is not satisfied, then I cannot use this expression for the sampling frequency, and then I need another representation of sampling frequency. Let us take one example and try to understand how I can apply this formula for sampling frequency. I'm considering a bandpass signal with FL equal to 10 MHz and FH equal to 10.1 MHz. As you can see, it's a bandpass signal present which has the frequencies present from 10 MHz to 10.1 MHz. So as per the definition, its sampling frequency can be given as Fs equal to twice Fh minus Fl, which will become twice of 10.1 minus 10 MHz, that will be nothing but 0.1 MHz, and this becomes 0.2 MHz. Before we call it a valid sampling frequency, we will check for the condition. Either Fh or Fl should be harmonic of 0.2 MHz, as we can easily make out that Fl, which is equal to 10 MHz, can simply be written as 50 into 0.2 MHz, and 50 into 0.2 MHz is nothing but 50 times Fs. Because Fl is harmonic of Fs, harmonic is nothing but integer multiple. Because FL is 50 times Fs, where 50 is an integer, I can conclude that Fs equal to 0.2 megahertz is a valid sampling frequency for this given signal.